Our next presentation is by Jason Tack, Conifer Management and Context. We'll get to talk about the big picture of more conifer removal in western landscapes. So, Jason, it's all yours. It's just advances, I think.
Gotcha. Okay. All right. Well, thanks, Charlie. Thanks, everyone, for being here. Appreciate you setting us the symposium. Great group of talks today, so I'm excited to participate, be here part of it. Basically, when I talk about what I do, I kind of focus on two things, which is use science to develop tools to prioritize where we do conservation, and then sort of take a step back and use whatever data we have to evaluate what were the outcomes of that work. And so I'm going to roll up kind of three projects here where we got to do a lot of these different things based off of Conifer. And Andrew did a great job of laying out all the great science that's taken place over the last 10 years. I'm really going to belabor that again because it's important and help set up the context for what's going on in conifer management in western rangelands. So again, a brief primer, we're talking about pinyon juniper woodlands within the sagebrush ecosystem. So these are been defined by high dynamics like on glacial time periods, right? There's been a lot of periods of successions and retreat over big time scales. And a lot of that has uncertainty associated with it in terms of what's historic rangelands versus woodlands. But as Andrew pointed out, one thing that's unequivocal is the massive expansion of woodlands since European settlement. He laid out the mechanisms underlying that, right? And so when we talk about just pinyon juniper woodlands, have about 100 million acres just in the western U.S. of that footprint. And the increase, especially within the Great Basin where we're at, has been about 2 to 6-fold. And unfortunately, about 90% of that expansion has occurred within our sagebrush rangelands. It's not just a historic issue, it's contemporary as well. So here's a quick slide that looked at significant changes in functional groups using trees as a functional group from a talk you'll see a little bit later here from Brady Allred. But if you focus in on blue, basically that's a statistical significant increase in tree canopy cover across the western U.S. over the past 20 years about. And if you just focus on where rangelands, where sagebrush is within this landscape, it's dominated by blue. It's dominated by an increase of woody cover. This is my favorite hockey stick. Andrew hit it. It's basically showing that you just can't give rise to sage-grouse populations when you have a small amount of conifer on the landscape. Sharon Barak-Murdo put this out about 5-6 years ago now. And one of the interesting things when I read that is this is really a stressor to populations. It's a natural feature on the landscape, but the impacts are tantamount to that of energy development on sage-grouse, tillage conversion, subdivision, like these big top-down anthropogenic fragmenting features that impact populations. But here it is with a natural feature on the landscape. And also, it's worth putting in this context, 4%, that's a small amount, right? The favorite analogy I heard was about 2 checkers on a checkerboard. That's what 4% amounts to. But when in Rome, right, we're in Reno, it's about 2 bets on roulette, which I still don't know how it works, but maybe tonight. Since Sharon's paper, and Andrew unpacked a little bit of this, it's like we've learned a lot more about the mechanisms driving that population level avoidance, where we just don't have sage-grouse in these landscapes. And we've learned that from Christian Hagen's lab and others that behaviorally, one, they just avoid it, right? Andrew showed this figure where once you get to 3%, particularly if they're spread out, they just don't nest in those areas. If they can avoid it or if they make a bad decision, they suffer demographic consequences. So nest survival, brood survival, all decline in the face of increasing canopy cover of juniper areas. And then, of course, adult survival suffers as well. So this is some great work out of the bi-state area by Pete Coates. Basically, once GPS-collared females encountered juniper, their movement rates went up. They started going faster, being less vigilant, making more risky decisions, and probably in riskier landscapes. And the survival with that increase in movement rates went down. One of the insidious things about this is that a lot of areas that western juniper tends to colonize are these wet, moist, mesic areas. Those are also areas that sage-grouse need later in the summer, and so it can actually act as an ecological trap where they're driven to these areas that are prone to be encroached by trees. So there's been a pretty massive response by management over the past decade. This has been going on for a while, but it's really ramped up due to a lot of work by NRCS, BLM, and others. And so again, Andrew mentioned this, what's getting targeted are these early successional phase 1, phase 2 woodlands where you still have that herbaceous sagebrush understory. And there's been a lot of tools, too, that have used science to guide us to where to go. So matching up high-density areas for sage-grouse with high-resolution maps of where conifers are to make sure that we're targeting these areas from a landscape scale and be really strategic with where we're putting our dollars for conservation. And so one of the first problems we ran into in thinking, how do we roll this up? What are the actual outputs of what we've done for conifer removal? Is a lot of different folks were out there cutting trees, and there's no systematic way of knowing like what's actually the footprint of what's been removed. What's the denominator? What have we done in terms of abetting this problem in sagebrush rangelands? And so this is some work by folks out of Colorado State, where they basically did that high-resolution conifer cover mapping on a 5-year schedule, and then just compared it. They said, where have we lost conifer, and was that due to management or wildfire? And so 2 things that really popped out to me in this is one, 1/3 of conifer removal was attributed to wildfire. So fire, this natural process, is still on the landscape, although management's really picked up the ball over the past 5 years or so. The other is, if you just total up everything that's been removed, it's a little bit over 500,000 acres, which is a pretty large number. But in terms of the footprint of pinyon juniper that's in this area, that's about 1.5%, right? And so that's actually on par with estimated rates of expansion. So at best, we're sort of keeping track with this expanding footprint. So those are the outputs from conifer removal. We've learned a lot from these great Baki type studies out there with sage-grouse, where we have outcomes now associated with it, actually behaviorally and demographically. So like Andrew said, instant habitat. Sage-grouse seem to colonize these areas almost instantly following removal. And my favorite anecdote is there was a graduate student in Utah, Charlie Sanford, who basically said he was following a radio Mark 10 tracking the masticator into some sagebrush area post-breeding season, right? There doesn't seem to be this lag effect, at least behaviorally, for using these areas. And then, of course, the 3 pillars of population growth that Andrew shows, right? Nest, brood, adult survival, all almost instantly increase following removal as well. So you get that demographic flush as well. These things propagated together shows what Andrew showed is that we actually have evidence for population level increase at landscape scales following treatment. Andrew's a modest guy. That was an awesome talk. We don't have a lot of examples of this, if any, for population growth from a restoration effort in terrestrial systems. That's pretty unique, and it's really phenomenal that we actually have this tool now in hand that we can demonstrate this success with. Also, as Andrew mentioned, it's not just sage-grouse, right? There are focal species for conservation in sagebrush ecosystem. Our assumption with the focal species is that they're conferring benefits to the other critters that are out there, and we found that with sagebrush-obligate songbirds. So this is some work from Aaron Holmes and others. In Oregon, it found also about 3 years past removal, we get 55% more brewer sparrow, 66% more green-tailed towhees who nest in sagebrush. So there's an actual demographic benefit from those critters as well. And then if we look at from a large-scale targeting perspective, where we find these other sagebrush obligates are highly aligned with where we've gone to remove conifer for sage-grouse, given this common denominator of sagebrush, right? I understand this is the Wildlife Society conference, but there's some actually cooler stuff that's going on too with conifer removal from an ecosystem side, right? Biodiversity is just one ecosystem service. 2 of the more interesting ones I found is you get this increase in an herbaceous understory, right? So our sort of stalwarts of resilience in these landscapes are perennial grasses and our shrub cover. And so we're basically able to improve that in certain sites. And one of the cooler ones is water retention. So when you have these pinyon juniper landscapes, the snow comes down, it packs evenly. When it starts to heat up in the spring, it melts quickly. You have a lot of bare ground associated with juniper, so it takes what precious little topsoil there is with it. And so you get a lot of sediment deposition and erosion associated with that. When you have these sagebrush rangelands, what happens is the snow packs up on the leeward sides of windblown ranges. And basically you get these reservoirs of snow that slowly deposit that water. And so you get more water later in the season when it's more valuable in these landscapes. So it's a great win for the communities out there, wildlife communities, and the producers as well. And so I hope I've convinced you that like this is a really interesting management technique that has demonstrated success across a wide range of factors that we're looking at. But one of the always questions in the back of our mind are, is there a chance we're creating winners and losers by doing this, right? There are species that rely on these pinyon juniper woodlands, and so it begets us to take an honest look at how have we done in terms of targeting away from some of these critters that might rely on this habitat type, and how well have we targeted for sagebrush obligates that are in need of conservation. And so the currency that we used for this evaluation was songbirds, because we got a lot of data on them, and we've got a lot of states that know sort of what their species of concern are in these areas. And so we got 9 different species here, basically sagebrush-obligate songbirds, songbirds relying on sagebrush, and then woodland obligates. So here's kind of the 5 big critters that rely on these pinyon juniper within sagebrush ecosystems. And one of the first things we did is just look at, well, how are they doing? Let's look at BBS long-term trends in terms of population trajectories. And so, not surprising, sagebrush obligates have followed the paradigm of sage-grouse, where we've got declining populations of brewer sparrow, sage thrush, or green-tailed towhee. And interestingly, woodland obligates have kind of followed this narrative of an expanding footprint of conifers. We've got increasing distributions of juniper titmouse, ashlar flycatcher, gray flycatcher. If any folks saw the recent science paper on trends in birds, that's fairly phenomenal, right? But there's one glaring exception, and that's the pinyon jay, where you have a species who's declining faster and more extremely than any other of these land birds in the system. So something interesting is going on there. So anyway, I'm just going to focus on these declining species now and talk about evaluating our past management and a path forward for prioritizing how we do this. So basically, we want to develop maps that were representative of distribution or abundance to show us, like, where are these critters on the landscape? Where's the habitat? Where's the population strongholds? And so we took all these different animals. We used BBS data because it was the most comprehensive data set we had for this geography. Basically, on the right-hand side of the equation, we measured a bunch of things that we know these species respond to: the landscape composition, fire history, is that things change over time, weather and patterns, topography, things like that, all the stuff that gives rise to where these birds might settle and then be abundant, and fit a bunch of models to it. And so basically, this is the output of that, right? We have these index to abundance maps that are now available on the Sage-Grouse Initiative map. I'm not a great cartographer. Brady is, so all these are available now. If you go to this map, you can interact with them, zoom in, zoom out, check the transparency, and sort of go to your neck of the woods and see what's going on. And so here we have just a quick shot of brewer sparrow, so you can see this largely matches up just with the distribution of sagebrush and the landscape. And then our pinyon jays as well, right, which are more southern, southwestern distribution, very abundant here in Nevada, but allows us to do certain things. And the first thing that we wanted to do was ask the question, how have past SGI treatments aligned with these distributions or indexes to abundance for these different species? And so, in particular, these declining species. And the reason we used SGI treatments is because we know these were done under the umbrella of sage-grouse, right? There's a lot of different reasons that you might go out and do conifer projects. We want to make sure that they're tied to this impetus behind sage-grouse. And so, not surprisingly, because these areas target those low canopy cover areas where there's high densities of sage-grouse, we found that cuts generally favored species that are known to respond positively to management. So brewer sparrow, sage thrush, or green-tailed towhee, both are, where cuts are taking place, are in areas that have higher predicted counts for those sagebrush songbirds. And importantly, cuts appear to avoid areas with high predicted counts for pinyon jay. So hopefully there's this disparate just habitat use in general, or where we're targeting for sage-grouse, we're avoiding this problem. But that was just retrospective. We wanted to go forward and actually give practitioners a tool to sort of say, where can you go to meet all these seemingly competing objectives at a landscape scale, to make sure we're doing right by sagebrush obligates, but avoiding these problematic issues with birds relying on woodlands who are declining. And so basically what we did is we took those high resolution canopy cover maps to show us where are those areas where we know we can have success, early stage, phase 1, phase 2 woodlands. And they basically married that up with high density breeding areas for sage-grouse, right? So this is what Kevin Doherty with Fish and Wildlife Service did, shows us where our hot spots are for grouse. On top of that, we now added are abundance maps for brewer sparrows. So we also have more of a community aspect of it, looking at birds that we also know respond positively to management. And then importantly, within this sort of conservation prioritization algorithm that we're using here, we said avoid pinyon jay distribution like the plague, right? Make a cost associated with going to these areas that might have high predictions for pinyon jay. Put that in with a conservation planning framework, and basically we get this big map like this. So the two take-homes from here, as you go from blue to these warmer colors, yellow, those are areas that get selected more on the landscape that meet those three objectives. Give me low density canopy cover with a lot of sage-grouse, a lot of brewer sparrows, and make sure I'm staying away from pinyon jay. And so basically it's selection frequency is the response variable there. That's how many times that particular area gets selected to meet all of those objectives. And so it's a nice landscape level planning tool in terms of where we might invest for continuing this conifer management to meet all these objectives. And one of the cool things is it really aligns with where SGI, BLM, and others have been working too. We can see a hot spot sort of there in northwest Utah that's been ground zero for a lot of work. Andrew study areas on here as well. And so it aligns up with what we've been doing, which probably explains the past figure I showed you about evaluating past cuts. So, but you can also zoom into an area too. So say you're just from Nevada and you're interested in where you want to do management, then you sort of scale that to your landscape as well and see areas that are important if these are your three objectives for conifer removal. So with that, appreciate you again for being here. Happy to answer any questions if I have time.
We have some time. Jason, on that last map that you showed, what was the resolution reaching?
Several square kilometers in there. I can't quite remember well. It's fairly large though, right? Larger than a typical project would be. No. Oh, sorry. Yeah, the question was how big was the resolution on that prioritization map we did? And the actual number's eluding me, but it's several square kilometers, so it's a fairly large footprint. So, yeah.
I went to a pinyon jay talk earlier with Great Basin Bird Observatory, and they were kind of tracking the movements of pinyon jays, and they were showing them maybe using edges in places where they had done some sage-grouse cuts, and then also like not like super thick juniper forest, but like somewhere in between where maybe there was like field treatment type of thing.
Yeah.
Anyways, I was kind of curious, like if you were able to look at that in terms of avoiding. Maybe we don't want to totally avoid pinyon juniper or pinyon jay habitat, but we would just want to be a little different in how we treat it. Anyways, I was just
Yeah.
at that Great Basin Bird Observatory stuff.
We've been thinking about that a lot. And, you know, one of the terms that we come up with is that maybe these sagebrush-obligates and pinyon jay are in the same arc of peril from this expanding but also like infilling footprint of conifer, right? So pinyon jay, I'm not an expert. The one thing that always pops out is they're tied to the pinyon nut, right? Pinyon nut production is everything. And pinyon nut production is driven by tree vigor. Tree vigor gets depressed when you get increasing densities of these trees, older trees. Like basically as things are infilling, also as things are encroaching, you may see pinyon jay suffering just as much. So I wouldn't say that we know perhaps what stand management might look for, but that's could absolutely be part of the portfolio for pinyon jay management. Good question. Yeah. Oh. Hmm. Yeah, good question. So the question was, you know, what about other taxa out there that aren't quite as able to disperse as like a migratory songbird? Data limitations is the thing there, right? We wanted to be sort of west-wide in this. I know there's some work coming out on pygmy rabbits. There's some reptile work coming out as well with the Sagebrush Science Initiative that Fish and Wildlife Service funded. So I would say hopefully stay tuned. We'll get into this area where we're becoming more data-rich in ecology, and we can appreciate that. So,
yeah, thanks for that. Are all those objectives weighted equally, and have you had any feedback from decision makers on, you know, if you had a chance to weight those differently, what that might look like?
Yeah, it's a good question. So the question was, did we weight all these three objectives equally when we were coming up with this prioritization? Yes, we did. we haven't had that much feedback yet on that. So that's interesting. There's a lot of user control when doing these things, right? And you make a lot of not necessarily objective decisions in that. And so something we could play with and just, yeah, it's probably right for feedback, right? Question.
I've got
Yeah.
one. Have we heard any feedback from folks that think planting trees is good for the global warming question about removing conifers, or has that come up in the past?
So yeah, Charlie's question was, have folks brought up the idea of planting trees to combat global warming? In this system, I don't hear that much. We've unified around a group of people who hate shade to really, that's my community. But one of the things so obviously, yes, junipers are going to store more carbon in this system. It's a lot more volatile source of carbon, though, right? You don't have low dense, or when you get these infill and these big stands of juniper, you don't have low severity fires. It gets hot, it's very volatile, and then you end up throwing that carbon right back in the atmosphere. Whereas our perennial understory and our sagebrush, deep rooted, the idea is that hopefully those are more, maybe our lower interest sort of bonds in our portfolio, but very much secure. So yeah, there's a lot of interesting work to be done there, though.
And you mentioned the other ecosystem services. You guys have certainly, like longer wet days with longer higher storage of carbon in the soil, right? Which is a large, impact.
Right. Yeah. No, good point. All right. Thank you.